This video is going to address creating tables and using those tables when you want to create data in memory locations, and so you don't have to get your program up and running, your ladder logic program up and running, and enter values in there manually. So what we're going to do is create a table for the purpose of entering a list of values in there, reading those into memory locations, and using them within the program itself. There are many other uses for tables. We're just going to stay on the simple and easy side. So I have a Visilogics program up and running. To create the tables, I'm going to go to this section of pull downs on the left hand side and select tables. You also could pull down to data tables and go to tables. It'll get you in the same place. So I'm just going to right click on here. Up comes the data table menu option for me to create tables, and this button on the left hand side is add table. I'm going to click that once. I'm going to give it a name. I'm just going to call it experimental table. Hopefully I spelled that right. Also, when you create a table, you have to create the structure. It's going to be very simple for us. We're going to create one column, and that column is going to have 10 rows or entries in there, so we can create 10 different values. I gave it a name. I changed the table size to set up the structure, and when I click the OK button, this is what comes up. Now, first off, the column 0 integer is a given name, so if I double click on that, up comes the properties that I can change for that. And I'm just going to change this to say numbers, and the memory data type that I can choose, or all the different options I have. For right now, I like integer. I'm going to keep it there. Obviously, the minimum and maximum values let you limit what can go into the table. I'm not going to limit that at all. I'm going to let them be the maximum for the integer value. You can set up the view as decimal or hexadecimal. I'm going to keep those in decimal number view. And there's a number of elements. We're going to keep it simple and keep it to one element at this part. These other two options that we have here, part of project or read only, allow us to alter. If we don't want to change the values once they're loaded in, we would set read only. And part of project means that we want to store it in program memory rather than data memory. So I'm going to store it as part of the project and make that part of program memory. We'll address those in future videos, a little bit more of the detail and why you would want to do that and what it does. But I'm going to click apply. And that's going to make the changes that I put in here, and I'm going to click OK. Now, if I want to enter values in here, I just double click on the entry that I want, and I can click a value in there like 15 and click apply and OK. And I can keep on doing that down here and changing each of the values within the ranges of the numbers that I got. I also could double click on here and say from row 2 to row 10, and I could click a value in here for 34, click apply, and then change to row number 3 and do minus 86 and click apply. And you'll notice if I click OK and go out, all these things are changing for us. By the way, when I click this 86, I could fill values in there also. So when I went from row 3 to 9 and I put a value in there, 65, and I click apply, you'll see it changed all of those. I don't want to do that because I want to have different values in this. So I'm going to go from row 3 to row 3 and put these values in one at a time. So in row 4, minus 145. I'm just clicking random numbers. Not really great at that. But in row 5, I'm going to put a 0 in there. And I'm going to fill the rest of these in here. Like I said, any way that you want to. It's not the best interface in the world, but who cares? We're not going to use this a lot to enter numbers in. But it does save us from entering them forcing them into memory locations while the program is up and running. So now that I have different numbers in here, and click OK, I've created my table now. Note too that I can have more than one table. So if I create another table, and I can make it 10 columns by 10 rows, keep the name table 2, click the OK, and I now can have 2 tables in my program at a time. Note that I did not set any of these parameters, so the tables can be stored in different memory areas. I'm not sure why they let us choose how to store individual columns in a table. I'm not sure why that is. I'm not sure why you would want to do some of them one way and the other way. I don't have enough experience with using these to do this. But at this point, you could create multiple tables in your thing. I'm not interested in doing that. So table 2, I'm going to delete and leave the experimental table in there. So I want to save this. And you'll note that my experimental table now shows up in the data tables pull down as one of the tables that I created. To use this, we would write a command. So basically, we could put a conditional button in here to say read table column. And I could click OK, and I could go to data tables and say data table read column instruction and put this in here. Okay, the source data, I have to pick the table. So the pull down lets me pick the experimental table. It lets me pick the row numbers. I want to read all 10 of these row numbers, so I'm going to click on here and use a constant. I could use a variable if I want to, but I'm going to start with row 0 because that's the way the tables were numbered. The indexes were numbered for there, and I'm going to put a constant in here and say row 9. So that's 10 rows that I'm reading, 0 through 9. We'll show you the table again if you didn't see that once we get out of this menu. Now, I have to say where I'm going to read it to. So I'm going to dump this into memory, and that was my whole purpose, to have a table that had a bunch of values that could load up memory locations without me having to do it manually. So I'm going to pick where I'm going to start. These are integers, so I'm going to stay with memory integer data type, and I'm going to put that into MI0. And remember, this is a vector. I'm going to read 10 values, so I'm going to click my nice little group of operands buttons. I'm going to say I'm going to read 10 values, right? And read column from table values, a little bit of a long name, and then I'm going to use my insert number. And when I click OK, what that's going to do is allocate all 10 of these MI locations when I read from the table to make sure I don't reuse them for something else by mistake. And I click OK. And I click OK here. And that does that. And if I go down to operand, or I can't do operands yet, but also it lets you either start with an offset. I'm going to read from the very beginning, so I'm going to include an offset of 0, and I click OK. If I go down to operands like I wanted to do a little bit earlier, you'll notice that I have this allocated, all these 10 locations, 0 through 9. I also said if I go back to tables, you can see the rows are labeled 0 through 9, not 1 through 10. And I have my program just about ready. The other thing I might want to do is go into this memory tab and define an operand that starts at MI0 and click OK. I'll stretch that out because I made such a long name for my variable. I am choosing a length of 10 and the bit size is 16 bits, so these are memory integer, and I can show these in decimal. This will set up when I'm online so that I can easily see these values all at one time rather than having to do the operand and scroll down through a list. Might not be a big deal with 10 values, but it's helpful, and it's nice to know how to set this up and do this. So I have my ladder logic set up. I probably want to display. I'm going to make it simple and just create a button in there. And when I hit the button, it's just going to read the values in. So I have to associate that with something. And we're going to associate that with the read table column to trigger off the read operation. And I'm just going to make my HMI pretty easy to work with and do. So I got everything set up. I'm going to download that to the PLC. And it will take some time as we go along here. There's nothing special about this program other than it's going to read from a table and put them in the MI locations. So the MI locations when we start will be whatever the last program that stored values in there was. And we'll give this another little second as we wait here for everything to download to the PLC. And what we'll do is show you the memory tab once this gets up and running. And when we hit the read button, it'll read from the table into the memory locations. Not sure if you remember exactly the values that we put in there, but we should recognize them after we put them, after we do this operation. So I'm going to go online. And also I'm going to bring the screen up so that you can see it in remote mode. And I'm going to go to our memory, and you can see there are a bunch of values in there. Maybe, you know, our screen is in the way a little bit there, but if I move it out, you see a bunch of values in there. If I click the button on the screen, I should do the read operation, right? Because when I look at my code here, it's very simple. I press that button, it happens, and I read the values that I have stored in my table into the consecutive MI locations. Okay? To convince you that that's exactly, it read in the right values, let me close this window, go offline, and go back to our data table again. And you'll notice that those were the values that were stored in the memory operand. If you remember that, I can go to operands if I was online and show you what those values were and that they actually changed and read that in. And this is a simple, easy way to use data tables.